Makes you feel like we might have a mess. Okay, perimeter. I'm not 100% because there wasn't any consistency in the answers I got. So I'm just going to go from shooting from the hip, unless somebody has something they want to tell me about this question that made it hard for you. Because again, the answers were all over the board. So I'm not exactly sure. So if I call this side A, we'll call this side B. I'll change colors so we can track it all over the paper. This will be a lot. And then side C. And this is not a right triangle, but we are going to make some right triangles. So from this point to that point, you're going to travel and make a perpendicular. Perpendicular means 90 degrees. We're going to count this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. As I'm writing this, I feel like we've done this before. There might have been me doing math by myself at home. So now I have a right triangle, and I can use Pythagorean theorem to solve for the hypotenuse, which would be part of the perimeter of this triangle. So remember, side squared plus side squared equals our hypotenuse squared. So 25 plus 25 equals c squared. What is the inverse of squaring something, guys? How do I undo? So I'm trying to get that c by itself. Remember, you got to type in the chat box to get those points this time. Make sure I know you're here alive and awake. What's the inverse of squaring something? Yes, thank you, Tasmin. So we're going to take the square root of both sides. Just so your future math classes are a lot easier than some. Every time you take the square root, you get a positive and a negative answer. Because 2 times 2 is 4, and negative 2 times negative 2 is a positive 4. We are discussing distance, so we're going to use the positive. For the sake of accuracy, because the square root of 50 is not a nice, neat number, I'm just going to leave it square root of 50 for right now. We'll come back. Because if I was thinking EOC and preparing myself not to panic, I don't necessarily know what kind of answer choice they want. So 1, 2, we're turning this into our right triangle. So we have a 3 by 2. So for side A, so 2 squared plus 3 squared equals, I'm going to still write c squared because of A, B, C, but we're solving for side A. 2 times 2 is 4. 3 squared is 3 times 3, which is 9. So it's going to give me 13 equals c squared. Again, not a nice, neat number. So I'm just going to leave it the square root of 13 equals c. And then last but not least for side B, so like I said, I'm using c because the formula, you could use x. The variable does not matter. The variable is absolutely the least. So if you want, like Tasmin, if it makes sense to you to put a here because it's side A that we're solving for, that's fine. Yep. It's up to you, but we have to make sure we train ourselves to do, especially because I've noticed it more in a virtual format, because between using Delta, using Khan Academy, using IXL, what I choose versus what you choose versus state test versus you leave Connect Academy, you go somewhere else, another teacher, another program, variables are so minimal, like what they choose, minus X and Y on a coordinate plane, because that's rule. Like that will always be, this is always your X axis, this is always your Y axis. Beyond that, they can change it however they want. Like there's no holds barred. So good question. Just make sure in your head you don't panic. You know, like, so I color code is why that's why I color code. So you know this was our pink triangle, purple. So the variable is not the end game problem, for lack of a better word. Okay. Yep. So we can call it bunny rabbit, smiley face, all the same thing. Okay. So the side A is square root of 13. So for B, we're going to go 1, 2, 3, 4, 5, 6, 7 up to. So let's get 7 squared plus 2 squared, and we'll call it a side bunny rabbit squared. 49 plus 4 equals bunny rabbit squared. So we have 53 equals bunny rabbit squared. Undo square. Yes, sir. Good job, Jay. We're going to square root it. So the square root of 53 is side bunny rabbit, or B, or whatever you want to call it, the green side. Perimeter is the distance around. So we're going to add all of those together. So square root of 50. And because this is very, very likely to be a calculator active question, you should be able to type it in your calculator just like that. And again, that gets back to where you don't have to round, because you know as well as I do, for some of you, that rounding is a little touch and go. Not horribly, not consistently do you miss it, but sometimes we just randomly forget that the third number is greater than 5 and we don't round appropriately. So it's 17.5. I'm sorry, 9, 5, 6, 7. So lots of upper numbers. On that one, 18 was the answer that I chose because it said round to the nearest whole number. I did do the math where if you square root of these all the way across, like as you went along, so the square root of 50 is 7.07. I know some of you guys are going to round that to 7.1, no matter how many times I ask you to do 2 decimal places. This is 3.605, so 1, and square root of 53 is 7.28. If you add these 3 together, you may or may not get, you will get close to 17.9 high number or 18. 18 is probably the best answer, round to a whole number. If you just round to whole numbers here, you would have got 17. Because 7 plus 7 is 14, plus 3 is 17. If you rounded inappropriate, actually, I guess no, you should have gotten 18 period. Because this should have rounded to a 4 if you rounded to whole numbers. Any question on that, guys? Oh, good, Jay. That's what I want to hear. Because again, I was looking at everybody's answers and they were like, whoo, wildly all over the place. Okay, good. Good. Now, I will throw in the wrench here. Likely, if this is an EOC question, they're not going to graph the triangle for you. Don't panic. You can graph points. Graph it and do the same thing. Okay? Also, I guess I would say another wrench, you're going to have that big puppy of graph paper, fold him into a corner, and make him nice and neat. Okay? All right. This one's a great question. I'm not sure that we fully understand what it asks. Great question, though. This was a renumbered from your check-in. We do have a check-in on Monday, too, guys. Sorry to be super random. It is required. That'll be your only work for Monday. I'll probably send out a survey and see if you want to have a live class on Monday where we'll just do some more EOC questions, or if you just want to focus on your check-in. I will send that out probably this afternoon because I know last check-in we did not do a live class because I know those can take a little bit of time. Sorry, random. Squirrel moment. Which statement is true about the function in the intervals -1 to +1? So we are looking at the portion from x is -1 to where x is +1. And that's not good because I didn't get there yet. There we go. So we're only looking at that chunk on our function. So from right here to right here. Is the function is negative and decreasing on the interval, so the interval being that -1 to +1. Negative is below the x-axis. This is your negative area. Positive is above the x-axis. Increasing means as my x increases, the y increases. Decreases means as the x increases, the y decreases. So as the x gets bigger, y gets smaller. As x gets bigger, if y gets greater, it's positive. It's increasing. So if we're looking at just this parabola, this side is decreasing, reading from left to right. Keep reading. It turns here, and then this is increasing. Is everybody okay with what I'm decreasing, increase? Bottom half is negative, top half is positive. That's a memorizational thing for most of you, I think, for most students. Not trick. You just gotta somewhere plan it in your brain. Thank you for all those yeses in the chat box. I love that. Okay, so function is negative and decreasing. Negative, it is negative. It is in the bottom half, but it's not decreasing because we're looking at this chunk right here. That's definitely increasing, so it's not that one. Function is negative and increasing. That looks good. Don't jump yet. EOC practice. Let's make sure we read them all. The function is positive and decreasing. So positive and decreasing would be from negative infinity, and that wouldn't be an equal, it would be that, to -5, because this is in the upper half and it's going down. Positive and decreasing. The function is positive and increasing. So positive again on the top of the x-axis would be from 1 to positive infinity. So this portion is in the positive and increasing. So these guys are not the chunk we're looking at. We are looking at the negative for the increase. Negative decrease would be from -5, going from here, because that's where it starts to be negative below the x-axis, until it turns at -2. I gave you a lot of information right there, but are we okay with decrease, increase, positive, negative? Perfect. That should be an easy one, I think, for an EOC question, don't you think? All they're saying is between these two numbers. Remember, it's always an x-axis. If there's the x in the middle, you're looking at, this is a little domain. So in the midst of this domain, is it increasing or decreasing? Okay, perfect. Man, we slaughtered this puppy too. It's a lot of words. I think that might be the problem. High point is halfway between. Halfway. As soon as you see the word halfway, your brain thinking midpoint for math class. Midpoint. You could say the North Pole in Antarctica. It doesn't matter. That's irrelevant. If Greensboro is located at 612, so ultimately, sometimes for me, because as you already know, I have the attention span of a squirrel. If Greensboro, so high point is the midpoint of Greensboro and Thomasville. That's our first sentence. If Greensboro is located at 612 and Thomasville is located at -8, -14, what is the distance between Greensboro and High Point? So we're looking for that distance. Now, you could do this a couple of different ways, your choice. Because we know High Point is the midpoint, you could find the distance of the entire segment and half it. Or you could find the midpoint and then find the distance of the G to H. I'm going to do midpoint and distance from G to H just for practice of midpoint and all of those, like all the content. So 6, we're going to add them because midpoint, remember, is x plus x divided by 2, y plus y divided by 2. Or as I like to do it, use my coordinate 1, coordinate 2, straight down, add. If I have 6 and I spend 8, what do I have? Or 6 plus a -8 is what? If I owe you $8 and I hand you 6, where are we sitting? There we go. That's what I want to see. This is that easy math stuff I'm talking about. All right, so if I have 12 plus what we could say and I spend 14, where am I sitting? -2 again, or I owed you 14 because that's negative and I paid 12. Then we're going to divide by 2 because it's midpoint. That means cut it in half. -1, -1. You could also graph this. I don't think I would want to go from +6 to -8, even though it goes the other way. It's a pretty wide spread on a large piece of graph paper, but you can. You can. Totally can. So this is our midpoint. We want to find the distance between G and H, or Greensboro and High Point in this case. So distance, again, you can graph them, or when we do distance, when we graph it, we do a squared plus b squared equals c squared. Once we make that into a perfect triangle, the differences in x's squared plus the differences in y's squared equals, in this case, would be distance squared, but your distance formula, they square root it to get rid of that. That is the distance formula. The distance formula is just a different font layout of Pythagorean theorem. So 6, I'm going from G to H, minus 1. When I minus minus, what happens to that negative? What happens right here? What operation does this turn into? Plus, right? So it's going to be 6 plus 1. Want to see that action, guys? What's 6 plus 1? I think I'm only missing a couple of you in the chat box. Good. Thank you, Tasmin. Yep. So that's going to be 7. So we're going to do 7 squared. We're going to do y 12 minus minus 1. Minus minus is going to make this a positive again. 13 squared. All right, I'm going to be quiet for a second. You guys come up with an answer. What number are we taking the square root of? Good. Of 218, right? The answer is not 218. I'm glad that we're getting these in the chat box because, again, this is another one. There wasn't a good consistent mistake in your class. It was all over the place. And I think some of us just didn't know what to do, period, too. There's always that. So now we're going to do the square root of 218. Remember, every time you take the square root of any number, you have a positive and a negative. If we're going to be really accurate, we're going to go ahead and go 2 places out. After that 6 is a 4. That's our distance. I will say some of you gave me the distance between Greensboro and Thomasville. That mistake I saw coming. Like, that makes sense because those were the coordinates you were given. To that mistake, I would say again, I think it's a great idea to sketch, like draw a picture. Pictures makes life way easier. That was when math was fun, when school was fun, when reading was fun, picture books, right? So draw a picture. Nobody judges the quality of your artwork, the straightness of your lines, the neatness of your handwriting in your pictures. It'll help you. Like I said, that first sentence, because probably after that, you lost high point all the way to the very end. And most of you won't go back and read again. So as soon as you see a period, if there's something you could illustrate or a note you can make out to the side, it makes it stick in your brain. So again, just thinking EOC skills and making sure we knock that one out of the park so we don't miss something easy. All right. This is an exponential. I know you guys said on word problems, setting it up, like just overall word problems for exponential were a little bit of an issue. This puppy is swinging hard for the fence on this one, though. There's a little kicker to it. So the population of small town in the year 1890 was 6,250. Remember, it's A1 plus or minus R raised to the T. That is going to be your growth or decay for exponential functions. That pen is not showing up very well. Sorry. What does A stand for? Always. Yes, good job. That's your starting amount, right? Whatever you're starting with. If you're depositing money in an account, if you're counting zombies, if it's a population, hopefully when you start seeing enough of these, you'll see that there's a trend in the conversation, which will also help you identify that it's exponential, not linear. As magical as they can get, there's only so many situations that work for word problems. So that's our starting amount. When would I add? How would I know if I want to add? Growth. Good, Zane. Yep, add if it's growth. So if I add for growth, then I'm going to subtract for decay. What is the biggest thing we've talked about that R? Where's the mistake that always happens with this R? Or what do we have to make sure to do to that R before we plug it into our equation? Does anybody remember? You do have to add and subtract the 1. Good call, because that is a mistake. You're right. Make it a decimal. Good, Jay. So we're going to take that percentage. This is our rate as a percent. But to plug it into the equation, we have to move that decimal. So to turn it into a percentage to a decimal, how do we change a percent to a decimal? There's lots of different ways you could say it. Divide by 100. Sure. Yep. Divide by 100 or move the decimal 2 to the left. And then, so if I want to go from a decimal to a percent, what am I going to do? Yeah, Jay, that's perfect. Too easy, guys. This is a trick question, 100%. Don't overthink it. If percent to decimal, I divide by 100. How's a decimal to a percent? What's the opposite of divide? Yep, we're going to multiply by 100. And if I move it 2 to the left to go from percent to decimal, the opposite to the left would be which way? Yes. Hey, I don't know if you're picking up on this. I'm asking you those kind of questions that are not math related so I can see you in the chat box. Yep, so we're going to go 2 to the right. Now, Jay gave us that our percent, so we are going to, it's increasing, so we are going to add. So 1 plus 0 point, there is an O, 375. Moving 2 to the left. We're going to raise it to the T. Our starting amount is at 6,250. What is the population of small town in year 1915? So we're tracking it from 1890 to 1915. This one I don't think we saw a lot of during our lesson, this style problem. As I've said before, the EOC, they give you the content and then they just make that puppy hard. When I raise anything to the 0 power, so think exponential laws. So anything raised to the 0 gives me what? Yep, you're on it. You knew where I was going. It's going to equal 1. So 1890 is going to be our starting point. That would give us, because if I raise this to a 0, all of that becomes a 1, and then I would be left with this. So 1890 is 0. And then I got to get to 1915. So how many is that actually? We don't want to put 1915 there because that's a hot mess. We want to know how many jumps is 1915 from 1890. How many years passed? If this is year 0, so like if we're thinking about our table, this is our years. So 0, which is 1890. And that's where we have 6,250. Yeah, good, Jay. 25. So we're going to raise this to 25. The big misconception is to raise it to 1915. Don't do that. If they give you a year and then they give you the next year, it's not the years you're using. This would be like your 0 year, your starting year, your y-intercept, starting point with your starting value, and this is where you're going to end up. So we're going to raise it to 25. You got a calculator in front of you, your Desmo's open. Somebody give me that answer. Perfect. Jay, that's absolutely correct. Yep, that's exactly what you would do. Give me those answers, guys. Again, a lot of people missed these style questions. Uh-oh. And that's what I needed to see. Because I don't know what's happening. So, maybe it's a TI-84. Did I put it in wrong? 6, 2, 5. No, make sure, because I make mistakes as much as the next person. So your starting amount, 1 plus 0.0. I'm going to imagine it's too small, so I'm not actually sure what happened. And you raise it to the 25. Jay, I'm not sure. It looks like we only added like 200 and something though at that rate. So, okay, missed the 25. There we go. That's it. So raise it to the 25. So in 1915, its population, so we have 15,688, 0.5. How many of you know there's 0.5 people? How many of you be freaked out if you're walking down the road or you went to Walmart to get something and you saw 0.5 of a person? Big weird, right? Not a thing. Can't do that. One of our ed puzzles, that teacher went hard in the paint, talking about at 0.5 and 0.4. Yeah, just some legs. Just some legs in Walmart. It's Christmas. They're allowed to decorate their tree too. Yeah, so make sure you're being logical. Can't be 0.5 people. That's not a conversation. We're not worried about the groceries or the expense of living for 0.5 a person, okay? All right. How's everybody feeling so far? Yeah, around him. We're just going to roll him up in a ball and send him down the turkey aisle at Walmart. All right, good, good. Yay. All right, this guy. I feel like it's not that ugly if you stop. I think it's ugly if you look at it and panic because we're math one and that's what we do. We're still kind of scared of some of this math, but we're way smart enough. As far as like popular math words, for lack of a better word, yes, Jay, that is the answer, but get rid of that 0.544 creepy human that's walking around Walmart. It's just 15,688 because we're not going to round him. We don't want to round him up. Weird legs would be a whole nother conversation. We would no longer be talking about the population or just an upper body. That would be weird. Or how about just a left side? That would be kind of strange too. Midpoint. Hopefully you see the word midpoint. What does midpoint mean? Halfway. Okay, I like halfway. What else? What else do we know? If our segment, if this is the midpoint, what do I know about one portion relative to the other portion? Middle, good. Halfway. It's in the middle. So, yeah, they're equal. So I know this one is going to be congruent to this one. This is also super like a not necessarily a thing, but if you run into it, that's going to stink if I haven't discussed it. If I have these two marked like this, and then I have double hashes, the double hashes are a pair. So the double hashes, these two sides to be congruent to each other, whereas these two sides are congruent to each other, but these are not the same. You shouldn't run into that. I feel like you may have seen that in middle school, but you know some of that stuff gets dumped into that black abyss in the back of our brain. So our dashes, if they match, that means they're the same, also known as congruent. Those are congruency marks. So that means this is congruent to this. I'm going to be quiet and see if you can give a go at solving for x. See if you can figure out what the value of x is. Please. What does everybody else think? Think we're right? Does anyone else think Jay's right? His answer is right? Stop it. Stop it. If we know they're congruent, we're going to set them up equal to each other, right? 4x minus 1 equals 3x plus 3. We're working in some hardcore math, eighth grade math, kind of solving equations right here. Not super difficult. Solve for x. Jay, you are correct. It is 4. I'm hoping the rest of you have not fallen asleep. You're just writing a little slower. I'm double checking all your work. So I move towards the positive x always. That's the direction I chose. So I'm x minus 1 or 1x. So I want to add 1, so x equals 4. Now, multiple choice question, that puppy's there. Is that what the question asked for? Right. It's not what the question asked for. It does discuss the midpoint, but it wants us to find DE. So if I know that x is 4, does it matter which one I actually plug it into? No, because they're the same, right? Good. So then 4 times 4 minus 1, or 3 times 4 plus 3 should give us the same answer. What's our answer? Good. It's going to give us 14. Perfect. Because it's 16 minus 1, 12 plus 3. Good job. All right, these guys, I've let these sleep for a minute. Literal equations, you're definitely going to see at least one. Promise. And it's probably going to be calculator inactive, which sounds terrible, but it's really a gift. You can't use a calculator for this anyway. So that's not one of those ones that you're going to have to count your fingers and toes. We want to solve for x. So our focus is to get this side by itself. What is the first thing in this problem? And this is a little bit of a, you might give me the wrong answer. It's all perspective. That most of you hate the most. Like you're like, oh, why does that happen? Can't stand that when that happens. Makes math super complicated. Yes, 15, I wrote 14. Good call, Jay. Sorry. Yep. 15. Sorry. Thank you. So solving for x. Jay, by now you should be used to me doing silly things like that. But yes, thank you. Solving for x. What is the biggest issue with this equation right now? For most of you. What's the part you dislike the most? X minus y divided by 3. The x minus y part. Okay, fair. Because it's all attached together. Cool. I love that you just stumped me. Because most students in the past dislike the fact that there's a fraction. So it's all over 3, right? I can't touch x minus y until I get the 3 out of the denominator. Yeah, right. You're like, I don't like any of it. The whole thing is ugly and I don't want to do it. Completely understand, Tasmin. How do I get this 3 out of the denominator? Yes, because remember, any fraction is just dividing by 3. So we're going to multiply both sides by 3. Whatever you do to one side, you have to do to the other. So that gets me 3m equals x minus y. Double check yourself. We're solving for x. And I say double check yourself because by the time we get to the EOC, you will have isolated y for all of a linear unit and all of these fun things, and you will go moving things inappropriately. So make sure on literal equations you check back multiple times for which variable it is you're trying to get by itself. Because it may not always be the one, like I said, y equals mx plus b. We always get y by itself. It's normal to be used to that gear. So we've got to make sure we slow down and think. How am I going to get x by itself? What's the next thing I'm going to do? Add y. Thank you, Jay. Add y. Add y. Can I combine 3m with y? No, they're not like, right? This is like monkeys and this is yo-yos. So we have 3 monkeys and a yo-yo equals x. Done. I cannot tell you enough how smart you all are, and literal equations should not be the devil. You treat them like they are such, and you let them spook you or punk you or whatever you want to say. It's inverse operations. Don't let it scare you. Think about what you need to get by itself and let it move. Okay, this guy's hard to read. I didn't realize it was because it was in color. 5x plus 8, 6x plus 2, 5x, and x plus 6. Now, shaded region is all of this outer portion. Hopefully you can tell it's a little darker. So what is the perimeter of this shaded rectangle? That's this guy. What do you know about rectangles? It's a silly question. Super silly, super easy. Think back to like middle school. What do you know about rectangles? Opposite sides are congruent or are the same. So that means this guy is the same as this guy, and this guy is the same as this guy, right? What do you know about their angles? Yeah, they're all 90-degree angles, right? Which means they're perpendicular. And what do we know about, like if this was on the coordinate plane, what do we know about the slope of perpendicular lines? Don't tell me we forgot. Perpendicular is at 90 degrees. And what do we know about their slope? Opposite and what? Yes, opposite and reciprocal, or opposite and flip. If you can get flip to stick to your brain, that's perfect. Okay, so perimeter, we're going to add these together. So this is 5x plus 8, 5x plus 8. And then we have 6x plus 2 plus 6x plus 2. And you can write it straight across. It's fine. You can stack them. You can multiply 5x plus 8 times 2. All of that's the same. So we have 12 plus 10 is going to be 22x. And then plus 20. That's it. In previous classes of students who talked to me, they said this is hard because 22x plus 20 is never an answer. Like it's not x is 7. So polynomials can remain polynomials. All right, it's 10 o'clock, guys. I don't want to keep you over. Hopefully I'll see some of you at EOC boot camp at 2:30. Otherwise, have a fantastic weekend, and I will see you on Monday.